Okay, so the last video I made was about 9 minutes long about f of x and limit as x approaches 1 or something. That's way too long. That video is going to take half a day to upload, but that's a very, very important question. Okay, so if you're in calculus, you need to watch that video and really understand those concepts. Okay, you need to understand the difference between x, f of x, f of a value of x, and the limit as x approaches some value of f of x, okay? Very, very important question. So if you have questions about that, send me an email. I'll make another video, try to explain that in greater detail, okay? This video is going to answer this question. This was pretty straightforward. I wanted to go quicker, so I already have it on the board, okay? This is about the velocity of something that's being dropped, I guess, from an altitude of 300, whatever, feet, meters, whatever. So we have a position function here, okay, that says that the position, or the altitude in this case, of a falling object is given by this function, okay? It's a function of time. If we want to replace the variable with a, we end up with a function in a. We can replace the name of this variable with anything we want. Then it says that the velocity of this object, when t is equal to a, is this. Now, this is actually the derivative, okay? The velocity is the derivative of the position function. And this is the differential quotient written in a different way. If we describe a as t plus some little delta, then this is the differential quotient. So this is a derivative. So this is given in the problem. So we have f of a, write that down. We have minus f of t, so minus f of t. Make sure you put f of t in a bracket because we're subtracting the whole thing, right? Got to have that in a bracket over a minus. All I've done here is substitute into what they've given you. All right? F of a, f of t, a minus. If you do the subtraction, the 300s go away. You end up with this, right? Minus minus is positive. Factor out the negative 4.9. You end up with this. Now you have a squared minus t squared. You should recognize this as a plus t times a minus t. Okay, we see this a lot. Then you've got a minus t over a minus t. It's a multiple, right? It's a factor here, so you can cancel it. We end up with this, negative 4.9 t plus t. Okay, now where did this come from? Here, we can actually substitute the t for the a, right? Notice that we can't just substitute t for a here because we're going to get 0 on the bottom of the fraction. So that's the thing that keeps us from substituting, right? But once we do this cancellation, we don't have a fraction anymore. Now we can substitute. We can just substitute t for a. We end up with negative 4.9 t plus t. So this is 2t. So that's 9.8, negative 9.8 t, which, if you look at that, that's the derivative of this, right? So 2 comes in front, you get 9.8 t. And the derivative of 300 is 0. We'll talk more about derivatives a little bit later. But anyway, so this is our velocity as a function of t. Now, they're saying we want the velocity when this thing hits the ground. So the position at the ground is the position function equal to 0, okay? So we're going to have this negative quantity and this positive quantity have to be equal. And if you do a little bit of algebra, you're going to end up with this being the t when it hits the ground, okay? So we plug that in here, and we end up with this. And this is good for me, but I guess Wettstein is going to ask you for some decimals. But anyway, that's how to do this one. Okay? So if you have any further questions about this, send me an email, and I'll try to answer them.